Assalamualaikum warahmatullahi wabarakatuh to all students. Okay, so in this video, we are going to learn Chapter 5, Network in Graph Theory for Mathematics Form 4 KSSM, a new topic in syllabus for Mathematics Form 4 for KSSM. Okay, so the first thing that we are going to learn in this topic is about network. Okay, so the learning standard for this today video is to identify and explain a network as a graph. Okay, so the first thing we are going to see what is the relationship between network and graph. Okay, so you can refer textbook page 130, Mathematics Form 4. Okay, so before we go to network, let's see what is graph. Okay, because we already learned about graph before. Okay, so basically graph is actually series of dots which either link or not link to one another by lines. And then the dots are known as vertex. The lines joining the vertices, okay, vertices is actually plural for vertex, okay, so the lines joining the vertices known as edge. So dots known as vertex, vertex adalah bucu, and the lines, garisan, joining the vertices known as edge. Edge in Malay is sisi ataupun tepi. Okay, so that's a basic definition of graph, and this is examples of a simple graph. Okay, where we have vertex here. Okay, the black dot here is all vertices, and the blue line connecting all the vertices we call as edge. Okay, so now what is network? Network is actually part of graphs with the vertices and edges having their own characteristics. So here the keyword is own characteristics. Network have their own characteristics. Okay, and it is actually a many-to-many relation. And this is examples of network. Okay, as you can see here, small picture here. Alright, so this is actually transportation network. Okay, transportation network. Okay, we can see in MRT, LRT, bus, and so on. Okay, another type of network is relationship network. Okay, Asri, Abu, father. The relationship is Asri is father to Abu, Alia is mother to Abu, Asri and Alia is wife to Asri, and so on. So we use network in many things. For examples, in transportation, network, and in systems, and finance, and so on. Okay, so let's see the notation that we are going to use in this topic. Okay, you can refer textbook page 131. Okay, so a graph is denoted by a set of ordered pairs. We already learned ordered pairs before, okay, where we write G. G stands for graph is equal to VE. Okay, this is what we call as ordered pair. Okay, what is V? Okay, so V is actually set of dots or vertices. So to make it simple, okay, V, easy for you, V vertices, V for V. So we write down V in the form of set notation. As you can see here, V is equal to V1, V2, V3, and so on until the end. Okay, so what is E? E is the set of edges. So E stands for edges or lines linking each pair or vertices. Okay, so E edges, V is vertices. So E also we write down in terms of set notation, and sometimes you can write down in ordered pairs. Okay, A1, B1, A2, B2, AN, BN, and so on. Alright, so the next thing is degree. So what is degree? Degree in this topic, okay, degree that we use in network in graph, okay, represents number of edges that connect two vertices. Number of edges. Okay, so degree is the number of edges, and then the sum of degrees, meaning the sum of number of edges. Okay, the sum of degrees is twice the number of edges. Okay, so this is the formula. The sum of degrees is actually twice the number of edges. So if the number of edges is 7, then the sum of degrees will be 14. Okay. So the important thing that we have to know is this one, info zone. G stands for graph, V for vertex, E for edge, D for degree, and this symbol here represents sum. Let's see what is simple graph. Okay, a very simple graph. What does it mean by simple graph? Simple graph is a graph that has no loops and no multiple edges. Okay, no loops, no multiple edges. Alright, so these are examples of simple graph. A, B, C, D. No loops. Loops is gelong. Okay, multiple edges is berbilang tepi ataupun berbilang sisi. So only one edge connecting each points, and there is no loop between all these points. So this is what we call as simple graph. Okay, let's see examples. Set the number of vertices, edges, and the sum of degrees for the following simple graph. Okay, we already learned before number of vertices, what is number of, how to find number of vertices, edges, and the sum of degrees. Okay, so let's see the first one, number of vertices. Okay, so this is our simple graph. Number of vertices, as you can see in this diagram, we have 1, 2, 3, 4, 5, 6, 7 vertices. Okay, ada 7 bucu di sini. All the dots are the vertices. So therefore V is equal to 1, 2, 3, 4, 5, 6, 7. Okay, in set notation, the question asks to find number of vertices. So we have NV is equal to 7. Okay, so let's see the second one, number of edges. To find number of edges, first we have to find the edges. Okay, so the edges are all the blue lines here. Okay, 1 go to 7, 7 2, 2 6, and so on. So we have E is equal to 1 7, 7 2, 2 6, and then 6 3, and then 3 4, 3 4, 3 5, and 4 5. Okay, so we write down the edges in ordered pairs. Okay, so therefore when we calculate, we have 1 2 3 4 5 6 7. So the number of edges also 7, and E is equal to 7. Then the last one is sum of degrees, as we learned before. Okay, on the previous slide, the number of degrees is equal to twice number of edges, 2E. So our number of edges here is 7. So 2 times 7. Therefore, the answer will be 14. So sum of degrees is 14. Okay, so maybe we can do another, okay, check the sum of degrees using another method, which is we find the number of degrees. Okay, what does it mean by D1 is equal to 1? D1 is meaning from the first point 1. So this is the first point 1. How many edges from this point? So as you can see here, there's only one edge going from this point here, D1. So therefore D1 is equal to 1. D2, so as you can see here, D2, okay, you can see that we have 2 lines crossing the circle that I did just now. So that means D2 is equal to 2. D3, we have 3 lines, 1, 2, and 3. So therefore D3 is equal to 3, D4 is equal to 2, D5 is equal to 2, D6 is equal to 2, and D7 is also equal to 2. So when we sum up all the number of degrees, then we have the same answer, which is sum of degrees is equal to 14. Same answer as we used the formula just now, 2E. Okay, so just now in the definition of simple graph, okay, simple graph means there is no loops and no multiple edges. So what are multiple edges and loops of graphs? Okay, so let's check it out. Okay, you can see textbook page 131. Okay, multiple edges means, okay, the edge that involve 2 vertices, and the vertices is connected by more than one edge. Okay, so connected by more than one edge. So that is what we call as multiple edges. Okay, disambungkan dengan pelbagai sisi. Okay, lebih daripada 1 sisi. So therefore we call as pelbagai sisi lah. The sum of degrees is twice, so it will not affect the sum of degrees. The sum of degrees will be the same, twice the number of edges. Okay, so what is loops? Loops involve one vertex in which the edge is in the form of an arc. Okay, di dalam bentuk bulatan. Okay, that starts and ends at the same vertex. So kita mula dan akhir pada bucu yang sama. Okay, so that is what we call as loop. Gelung, macam gelung. Okay, we start and end at the same point. And each loop will add 2 to the degree. Okay, degree means the number of edge. So each loop will add 2 to the number of edge, or 2 to the degree. Okay, so these examples, as you can see here in this diagram. Alright, so normal edge are the lines that connected vertices, so PQ here, QR, RS, ST, TQ, QS, and so on. So these are edge. But as you can see here, PT, we have one edge here, the straight line, and then another edge here, okay, which is the curved line. So PT is actually examples of multiple edges. From P to T, we have 2 edges, the first one and then the second one. So that is what we call as multiple edges. And then at point R and at point S, we have loop. Okay, loop means that we start from a vertex and then we end at the same vertex. Same goes to S, start at the same vertex and then end at the same vertex. So this is what we call as loop, and this is what we call as multiple edges. Okay, so let's see examples here. In the diagram, okay, the graph is denoted by a set of ordered pairs G, V, E, where V is A, B, C, D. Okay, here we have 4 vertices, A, B, C, D. Alright, so what are the edges? Okay, as we can see here, this is all the edges. So we start one by one. E is equal to AB, the first one here. E1 is AB. And then the second one is AB also. Okay, E2 is AB, E1 is AB. So AB, AB. And then AD. And then BC. E4 is BC. And then E3 is also BC. And then BD, CD, and DD. So the loop is written as DD. So as we can see in this example, okay, when we write something like this, AB, AB, BC, BC, that means it is a multiple edges. Okay, we have 2 edges that connected point A and B. And then here, when we write down as in this form, DD means it shows loop. So from this one, the number of edge will be 8, as we calculated 1, 2, 3, 4, 5, 6, 7, and 8. And to find the number of degree, which is 2 times E, 2 times 8, which is the answer is 16. So if you would like to check, okay, check using the number of degrees, the first one, DA is equal to 3. How we get 3? Okay, recall back. Okay, maybe you want to do a circle. Oh, sorry, not clear. Okay, do a circle here. So we can see that we have 3 lines intersecting the circle that I draw on point A. So that means the number of degree from point A is 3. So from point B, we have 5 lines, isn't it? 1, 2, 3, 4, and 5. So therefore, DB is equal to 5. Okay, and then DC is equal to 3, and DD is equal to 5. How do we get 5? Okay, because here, when we do a circle, we have 3 lines at the bottom and the loop. As we recall back just now, loop will add 2 to the number of degrees. So we have 1 here and another one here. So therefore, at point D, we have 5 number of degrees. And so when we sum all the number of degrees, we will get sum of degrees is 16. Okay, still 16, which is same as 2 times E. Okay, so now let's check how are we going to draw a graph based on the given information. Okay, so from this example, the first example here, we have draw a simple graph. Okay, the information given is that we have V, which is the vertices, is 1, 2, 3, 4, 5, and 6. And then is given E, the edges that connected the vertices. Alright, so the tips in drawing the graph is, the first thing adalah draw the vertices. And then you draw the edge. Okay, so I draw the vertices first. Randomly put the vertices 1, 2, 3, 4, 5, and 6, and then draw the edges according to the question. So let's see, I start with here 1, 6. So draw line joining 1, 6, and then 2, 6, and then 3, 6, and then 3, 4, 3, 5, 4, 5, and 5, 6. So this is the answer for this question. Okay. And remember, in drawing the graph, this is not the only shapes that you will get. Okay, the shapes of your graph depends on this, the location of your vertices. For examples, maybe some of you will draw like this. Okay, still the same edges and the same vertices, but different shapes because you locate all the points differently. And then, or maybe something like this. Okay, so as long as you connect all the vertices with the correct edges. Okay, so let's see another example here. We have V is equal to PQRS. Okay, the vertices are PQRS, and then we have the given E here. Alright, so same as before, we first draw the vertices, which is P, Q, R, and S. Okay, randomly. And then draw the edges according to the questions given. So maybe you want to start from the left, from the right, is up to you. For example, this one, I would like to start with PQ and RS. So PQ, RS. And then I start with PS, PS. So what does it mean with PS, PS? As we recall, PS, PS means multiple edges. So PS, PS. We have two edges connecting PS. And then QR, QR. Okay, we have QR, QR here, meaning two edges connecting QR. And then PP. What is PP? PP means loop. Okay, start from point P and ends also at point P. So PP loops, SS also loops, QQ loops, RR is also loops. So this is the answer for the second example. Okay. So how are we going to determine whether a graph can be drawn or not? Alright, so let's recall back. The sum of degrees for any graph, okay, as given in the formula is equal to 2e, twice the number of edges. Okay, so if we have 2 here, that means a number must be an even number, isn't it? Okay, any numbers multiplied by 2 will get an even number. So therefore, as you can see examples here, okay, determine whether a graph with the following degrees of vertices can be drawn. Okay, so the first one, 3, 2, 2, 1, 3. This is the number of edges. So when we find the sum of degrees, okay, the answer will be 11. And we know that 11 is an odd number. So the graph cannot be drawn because the sum of degrees is odd. So in order for us to determine whether a graph can be drawn or not, we have to look at the sum of degrees, and the sum of degrees must be even number, as you can see in examples 2 and example B, sorry. So example B here, when we find the sum of degrees, we get 12. So 12 is even number, and therefore graph can be drawn because the sum of degree is an even number. Okay, so we will recall back what we have learned in these slides in this video. Alright, so the first thing is that the definition of graph and network, okay, and then we already know the important notation in graphs and networks, and then we know what's the definition of simple graphs, multiple edges, and loops, how to answer the questions involving all these three things, and drawing graphs from given informations. Okay, so stay tuned and let's check it out what we are going to learn in network in graph theory for part 2.